Well, thank you everyone for being here. We have a fantastic speaker tonight. Just a few items. So first off, my name is Shannon Sheehy. I run the careers team at CodeU. The careers team is working on some fun, engaging events and opportunities for you all. So keep an eye posted on Slack for those. We are hoping to do at least one more hiring event here in coming months. If you are a part of the January cohort and you are attending for your tech event requirement, please fill out the form in Top Hat. I believe it's near the top of your curriculum. There's just a short form you need to fill out letting your career coach know what event you attended. A couple housekeeping items. Please keep yourself muted. If you do have a question, there's a hand raising feature. You can also throw any questions in chat. I will monitor that. And if you want to if you want to ask questions in chat, you can. And then if you want to wait until the end, we usually have time for questions then as well. So with that, I'm going to go ahead and hand it over to David Merk, who is a quite an OG, I think, with Code Louisville. He was with us years ago as a student and mentors for us now. And he's going to present on You Need to Learn Object-Oriented Programming and AI. Thanks so much for being here with us, David.
Hey, thank you so much, Shannon. I just want to make sure you guys can see my slides. Is that correct?
Yep, looks great.
All right. Okay, so this is a presentation I started putting together earlier today called You Need to Learn Object-Oriented Programming and AI. And this is because I've been talking to a lot of people in the industry. And right now, because it is so easy to write code, we're seeing a lot of people with great prompting abilities, but not as much programming abilities. And I want to kind of make it easier to understand what you actually need to know of each, because I think AI is here to stay, but I don't think that it eclipses object-oriented programming. A couple of fun facts about me. I can bench 315 pounds. I did that the other day and felt really good about myself. Also, I've got a mean gluten-free cookie recipe, and if you stay till the end, I will share it with you. I am an engineering manager at a company called Zywave. We build insurance software for insurance brokers. We do that for the 10 of the top 10, 100 of the top 100, 1,000 of the top 1,000. So our user base, our customers kind of spans the spectrum. At home, I use Codex. At work, I use Claude. So I've gotten to get my hands dirty. And as Shannon mentioned, I'm Code Louisville alumni. There are a couple of links that, if you're interested, you can see some of the thoughts I publish on my website. You can see tonight's project on my GitHub. Or if you just want to ask me a question, LinkedIn is a really good way to start a conversation with me. Before I dig too deep, I want to ask, and it's okay to raise your hands on this one. Is anybody afraid of AI? These things are a lot more fun for me if people are like saying things or like raising hands. So I'll wait a minute. And while people are raising their hands, I will tell you all about Rocco's Basilisk, because it's this totally real internet meme about AI getting so advanced that it invents time travel, and then it goes back in time to punish anyone who would stop it from coming into existence. And so Rocco's Basilisk is all about, once you know about it, you have to do everything in your power to bring it into existence. It's totally real, super fun to talk about. Probably not my biggest fear as it relates to AI. Some of the people who put your hands up, though, if you were brave enough, tell me what you're afraid of as it relates to AI.
Hey, job loss is the biggest one for me.
That's probably really scary right now, especially going through Code Louisville. Anybody else, or is it job loss for everybody?
As a teacher, student reliance too much on it.
Oh, sure. So like people don't need to learn things, so they don't.
Exactly.
Anybody else?
I would say probably greed at most. That kind of ends up leading to things like job loss or just lesser quality things in general.
Yeah, capitalism being like zero sum. That's a good one. And so I'll quickly give you guys my take. Jensen Huang says this all the time. AI is a 5-layer cake. It's the energy that we're building out, the chips that he's building out, the infrastructure that Amazon and AWS are building out, the models that OpenAI and Anthropic are building out, and the applications. That's us. Those are the things that we're all supposed to build out. But I think that there's probably a 5th layer, maybe the cherry on top, is this concept of FOMO, or the fear of missing out. I think that's really what keeps this cycle expanding so fast. So while I do think that the job market's scary, and I do have concerns about my 401k, I do think that a lot of it is just we're finding out how to use these tools. And that's why I think you need to learn object-oriented programming, and you need to learn AI. Because I can't tell you when you will be able to just work with AI. But I can tell you that if you apply object-oriented programming principles to AI, you will be top tier. So I will go ahead and kick us off. Uncle Bob, is everybody familiar with him? He is the godfather of object-oriented programming. He wrote the book Clean Code. I don't know if you all can hear whenever I push play on my side. So if you can't, just let me know, because it would be really boring for me to watch 2 minutes and 40 seconds and you all to have no context. I don't know why I did that. I've got it open right here.
We cannot hear it, David. I think you might have to share the tab.
Yeah.
Specifically. We've run into that with some like demo day and other presentations. If you want to
That's
try that.
awesome. I did not know. Okay, here we go. All right, one more time.
You a day. Face it. The AIs will outcode you many times to 1. There is no task that would take you a day that the AI can't do in 5 minutes. It's over. You are not going to be the ones writing the code. I know. Deal with it. But here's the thing. That gives you a lot of power, because now you can do things that you never would have dreamed of doing before. For example, think about test coverage. You know what a pain that was. I mean, you've got to write all these damn tests, and you know the tests don't really mean that the code works. So you run code coverage and you kind of smirk at it and go, yeah, well, okay, but doesn't mean the code works. It just means it's executing. Well, you can fix that. Now you've got the horsepower. You tell that AI to cover the damned code, and then you use a mutation tester. Yes, that's a tool, and you have the AI build that tool for you. It'll only take it about 5 minutes, and then you have the AI run that tool, and the tool will make changes in your source code and run all the tests, and if the tests don't fail, then it'll write a test to make it fail, which means that you will have test coverage. By God, you will have test coverage. And then you know what else you could do? You could analyze the code for quality. You could write a tool that looks at the cyclomatic complexity. In fact, there's a great tool for this. It's 20 years old. It's called CRAP. Good name. I don't know what it stands for. I don't care what it stands for. It is a combination of test coverage and cyclomatic complexity. And you can tell the AI, drive the crap down to below 5.
Okay, so that's just that you guys. That's like 90% of his thoughts, right? His thoughts are, you're not going to be the ones writing code anymore. And I see this in my day to day. I see this in the engineers on my team's day to day. We still write code, but we don't write as much code. It's very specific when we are writing code. And what I think is very powerful is that you can take on more ambitious projects, right? You can write all the unit tests you want. Mermaid diagrams. Has anybody heard of mermaid diagrams? Super cool. You can check them into GitLab. They use mermaid syntax to diagram out UML. These are things that I would never before spend time building, but now I can. So you guys see Uncle Bob again. He says you'll never write code again, but you'll do higher level things. Are we all on the same page? Okay, cool. All right. Next one. This is another internet personality. He's saying code is cheap, maintenance is expensive. I think we're gonna need to watch it on YouTube, so I will share that screen now. And I know you probably didn't know that you're going to come here to watch me watch videos, but it's going to get more exciting than this, I promise. This is Nate B. Jones. He is the authority on AI strategy and news. I don't recommend following him if you have imposter syndrome. He's putting out more content than most people can have time to take in, but I do like the thoughts that he expresses here. Title of this video, experienced developers took 19% longer with AI. So,
bottom of that J curve right now, and many of them are interpreting the dip as evidence that AI tools don't work, that the vendors did not tell them the truth, and that the evidence that their workflows haven't adapted is really evidence that AI is hype and not real. I think GitHub Copilot might be the clearest illustration of this. It has 20 million users, 42% market share among AI coding tools, apparently. And lab studies show 55% faster code completion on isolated tasks. I'm sure that makes the people driving GitHub Copilot happy in their slide decks. But in production, the story is much more complicated. There are larger pull requests. There are higher review costs. There's more security vulnerabilities introduced by generated code, and developers are wrestling with how to do it well. One senior engineer put it really sharply. Copilot makes writing code cheaper, but owning it more expensive. And that is actually a very common sentiment I've heard across a lot of engineers in the industry, not just for Copilot, but for AI-generated code in general. Most organizations.
So, Nate B. Jones, worth checking out. His take is that AI is making code cheaper to build, more expensive to own. I agree with this take as well. I've talked about it a little bit in some of the entrepreneurial circles. We're able to build things faster than we're able to ask if people need things. Which I think is a really exciting problem to have, right? We can now build something and test it in less time than it would take us to debate if we should build it or not. So that opens up the world to opportunities. I've got one more for you, and then because I want you all to know what people much smarter than me are saying about this stuff. So I've got one more for you. This is CTO of YouTube, but he is the serious CTO. And I use the word basically very liberally. So we can take a look at this one. And let me get past my ads. All right, and now I will stop sharing and share a tab. So this is a video titled "The Hidden Cost of AI Coding." So this, to me, this is what we should all be looking at. What is the cost? I don't think businesses are going to stop using it. I got my daughter just fell down, I think. I'll be right back. It's okay. That's okay. So this is the series CTO, the hidden cost of AI that's destroying engineering teams. We're going to listen to maybe a minute, maybe two.
It says, but the blueprint was written for a different building. Everything fits, nothing works. Duplicated code blocks increased 8-fold in 2024. That's not efficiency. That's a write-only culture. Nobody is refactoring because it's faster to generate something new. So before you merge AI output, ask yourself one question. Does this code know why it exists? If the answer is no, you're not done. 45% of AI-generated code contains security flaws. That's not a fringe finding. That's Veracode analyzing over 100 LLMs. AI fails to defend against cross-site scripting in 86% of relevant samples. Log injection, 88%. Hard-coded credentials show up at twice the rate in AI-assisted development. The reason's pretty simple. LLMs are trained on public repos. Public repos contain decades of insecure code. The model can't tell a secure pattern from an insecure one by prevalence alone. It just produces what it saw most. This isn't a performance problem. This is a liability problem. If your system handles financial data, healthcare records, or physical infrastructure, the AI wrote it is not a defense. It's an admission. Treat AI-generated code in high-risk areas, auth, payments, surface boundaries, like untrusted input. Review it just like that every single time. Here's this productivity paradox nobody talks about. AI makes junior developers faster at generating code. That's true, but research across 2,755 projects shows that senior developers reviewing that code, they see a 19% drop in their own productivity. You're not getting 55% gains across the board. You're redistributing the cognitive load into the people who can least afford to lose time. You're freeing up your juniors by loading up your seniors.
All right, so that's another one. Just I like that one. That one's stuck out to me specifically because of three things. One is the this idea of Brandolini's law. The idea that it takes longer, and now you guys should see my PowerPoint again. That's my thought. You guys see PowerPoint?
It's saying
We're seeing the website.
kind of saw it. Yeah.
Here we go. Let me try this. All right, Brandolini's law. It's the idea that it takes longer to disprove something than it does to actually just build it from scratch. So a lot of times, what I'm seeing at work is that I've got smart engineers who are trusting AI, but then making big mistakes because AI was very confident. And so they thought that there was another endpoint in AWS that just didn't exist. I think another big risk here, like he says, is that AI is trained on public repos. Public repos have the largest attack surface area. So the risk from a security perspective is that as soon as you launch something, it's already hackable because there's already been an AI trying to hack it. And I think that the reason why it's so important to kind of show you guys these three different takes is because of leverage. I want you all to understand as you enter the workforce what your leverage is. You're going to be competing with a lot of people who are really good at prompting. In a world where anyone can build anything, what sets you apart from anyone else? That's the risk, right? And so this presentation is designed to give you some technical leverage. The idea that you can fix some of the mistakes that the serious CTO is referencing, right? You can review code so you know what the AI is doing. You can, a big one I see a lot of engineers fall short on is understanding the full software development lifecycle. So understanding what happens before and after the LLM, right? So before is the needs for gathering, right? You want to ask questions, understand what the LLM actually needs to do. And after that deployment piece, that's, I think the best developers I know are starting to learn more about how to deploy their own code, get it into production, and do it without becoming the bottleneck to an AI system. So that's your leverage. Now we're going to get into an OOP exercise. We're going to build a cookbook. I don't know how many of you guys have built cookbooks. I don't know why I even clicked that. I've already got it open over here. We're going to kind of learn the 4 pillars of OOP by building out a cookbook. And we're going to do it as a diagram, just to kind of create a mental model of what we're building. And then we're going to do it in code as well. So you guys just call things out. I'm going to just start throwing them on here. So I want to see at least somebody unmute first. The 3 things that we're targeting will be objects, properties, and methods from the perspective of a cookbook.
Ingredients.
Boom. I love it. Okay, cool. You don't have to raise your hand. Just yell it out. I'm right here.
Oh, I was going to ask you what exactly is a cookbook? This is the first time I'm hearing this term being used.
Oh, great question. Okay. So I am not a great cook, but my mom is a great cook. She made a book full of recipes that she has given to me. And so as a result, I now have a recipe for my grandmother's chip dip, right? Or on my own, I have discovered the world's best gluten-free chocolate chip cookie recipe. I told you guys about this a little bit earlier, but that also lives in the cookbook. Does that make sense?
Yeah.
So we've got some cookbook database. It's going to have and then we've got some ingredients. What else do we need?
A recipe.
Boom. We need some recipes. Okay.
Instruction.
Right. We need what's that?
Instructions or steps.
Yeah. Okay. Steps. Perfect.
Method.
Tools.
A couple of things going on at the same time. We said
Sorry.
what? I want you guys to compete. Keep yelling it out. It's good. This is more fun for me.
Baking tools.
Tools. I love that. Okay.
Yes, we both said the same thing.
Equipment. Methods.
Okay. We need. Okay.
I'm a cook by trade.
Yeah, okay. Cook by trade. Matthew. So
Yes.
Don't tell me method. Tell me a method. Give me a method. Anyone. Or cook. What do you
Instruction.
do? Instructions?
Yeah.
Okay. Okay. So you execute on instructions, right?
Yeah.
Okay. So what do you call it? What would that be like? You would give me an example of how you would execute.
Like technique.
Okay. Technique. Okay. Let's dig deeper. Or maybe dig more surface. because I am not a cook by trade. One method I was thinking of was like cook. I thought that might be a good method.
Okay.
Right. So this is an action that. Tell me if you guys see it differently. I think that a recipe has a list of ingredients and a list of steps, and maybe. What do you think is there a relationship between steps and tools, Matthew?
Yes.
Yeah, right. Like, so what do you think? Do that. I'm not a great cook. I'm gonna humble myself right now. I trust your judgment, Matthew. Do the tools? Which one owns which? What's that relationship look like? The steps have tools. Steps use tools. The steps are tools.
Step first is gather tools, I think.
Gather tools.
So,
I
so
love
you
Okay.
you follow the recipe, and then instruction would be ingredients. By ingredients, you get tools. That's
Okay.
the step. Equipment, tools. You know, next is station. What do you need? Are you grilling, baking, saucepan, butchering? So I never really built this, but I know how to cook. So
Yeah. No. I mean, that's. I think that we're saying the same things, right? So, like, there is some amount of logic in the gather tools mechanism, right? Maybe it's the steps or the ingredients that tells you which tools to get, and then you use those when you're completing the steps. I like that. So, I mean, to me, we're talking about the data and the methods. I think we've got it. For the recipe, we have ingredients, steps. For the methods, we've got gather tools and cook. What are some properties that we could put on the ingredients?
Possible allergens.
Sorry, go ahead.
Possible allergens.
Okay, yeah. I don't know how to spell. Guys, don't judge me. Okay. All right, what's another one?
Sorry, that's just something I always have to consider in my cooking.
yeah.
Courtney, what are you allergic to?
Mushrooms specifically.
Oh, wow.
Yeah. My daughter is allergic to nuts, egg, dairy, and gluten.
Wow, yeah.
So I'm trying to stay away from, like, professionally, it's more cross contamination, I believe
Yeah.
that's the word. So
Okay.
Yeah.
What about like a measurement?
yeah.
That's to me, that's a property on an ingredient. Well, I think the obvious one might be name, right? Like the ingredient has a name. What else? Or just name. Let's dig in. Give me. I'm not going to tell you guys my chocolate chip cookie recipe yet, but name one ingredient that you think would be in chocolate chip cookies?
Chocolate.
Chocolate. Yeah.
In a gluten-free recipe, I'm guessing like barley flour or oat flour or something.
Yeah, flour. Flour, that'd be good. And then what else would you do to model that as an ingredient? Is there anything else that you guys can think of? We might have it all. I don't know. We might. I just want to ask.
Measurements.
What's that?
Measurements.
Yeah. Okay. So we got the measurement, but I think that you're talking about like Oh, are you talking about quantity?
Yes. Yes, that's a good one. That's a good way to put it.
Yeah. Great call out. All right, Matt, you are our chef extraordinaire. Anything else we're forgetting here, or do you want us to keep moving forward?
I think that's it. I believe that's all in my head.
Cool.
But every time I cook, I try to simplify stuff, so it's really hard for me. You know.
That's a great skill set. That's a great form of leverage, right? So yeah, I mean, at the end of this conversation, we'll have technical leverage to talk about object-oriented programming, but your ability to break things down, to systematize, functional decomposition is a huge point of leverage in our industry. We call these things vertical slices, and we want to build them one at a time. And when we build enough of them, we get to sell them to people. So your ability to break it down so that we can sell things to people earlier, right? Like maybe we can sell people a chocolate chip cookie without chocolate chips. That's a win. You know, that is valuable to businesses. I think it's really important that everybody on this call learns their leverage. One of my mentors said that he hired a bomb defusal technician, which is the craziest thing in the world, to be some kind of a engineering leader. And his thought was, this guy takes risks. Like, so that the leverage was the ability to take calculated risks. Because if this guy was going to be willing to blow himself up for that job, maybe he would do the same thing for this other job. What about steps? How would we model steps? Any thoughts? Or instructions? This is the big one. Matt, you called this one instructions, right?
Yes, instructions.
Okay.
Or we usually put on instruction. We usually add like method of cooking. Are you gonna basically? So you're basically either you're baking, mixing, or I'm trying to think of it. So basically, if you're doing your cookie recipe, so we're baking today.
Well, okay, yeah. But what if we're going to do a grilled cheese? I've got an ancient family gluten-free grilled cheese recipe too, bud. Don't discount that.
Then
what's that called? Is it grilling?
Grilling.
Okay. Okay. What else? I thought you said mixing.
I try to think of a better word. Say,
Theo, what do you got, man? You have anything you want to chime in with?
No, I was looking through. Oh, I'm sorry. Go ahead, Courtney. I'm sorry.
No, it's okay. I was just saying maybe stirring.
Yeah.
Okay.
Yeah, stirring is the same as blending. So if you're stirring, then it kind of depends whether you want to break down and blend or you want to puree, but we're not going into puree. So stirring.
Theo, man of many talents. Okay, cool.
Oh, I try to do a little something.
All right, so let me challenge you guys a little bit on this one. We have like these, I can see all these, right? We got encapsulation. The ingredients have their own properties. The instructions have their own properties. The recipe has a collection of properties. Is there any chance that maybe these methods of cooking are actually different types of recipe? Like, just for example, maybe we've got a grilling recipe. And I know that if I've got a grilling recipe, then my cook method might turn on the grill. Or my bake recipe might turn on the oven. You guys can tell me I'm wrong. It's okay. It'll be a much shorter conversation if we do. But I'm here for it.
I would say technically there are some recipes that would use more than one method of cooking.
For sure. Yeah. If this were what do you think that would look like?
Category?
It could use more. You said more than one.
Yeah, there. I guess, like for example, I guess some broths From what my family does, they cook rice separately from cardo, a Mexican cardo. So they roast some vegetables, then they add it into the broth. They already have like some of the meat boiled, and that's in the broth already. The rice is cooked differently as well. So I guess it would be different sections of a recipe itself. I wouldn't know how to explain it properly.
No, I think that's good. Okay, so kind of what I'm hearing is that each instruction can have its own tool.
Yeah.
Okay, that makes sense.
Yeah, and then when you look at the grilling and your baking, you're looking at a different convection. Say grilling, you got charcoal, a heat source, and say a lighter or a fire. Now you're baking, you might have your oven, you have your direct go-to heat, where you know there's not a lapse in. If you're cooking, you don't have to worry about a lapse. Where grilling, if your charcoal goes out, now you got a different story. So it kind of depends on that source and that convection, pretty much. What I'll say, with grilling and baking, per se.
And I think I get where you're going with this, because for a computer, you've got to write out exact instructions for every step of the process. There is a teaching technique for object-oriented programming that I've used in coding classes, where I have students write down the steps that they think it is to make a peanut butter jelly sandwich. And then I will follow their directions that they write down exactly. For instance, put the peanut butter on the bread. They didn't say open the jar. They didn't say put it on the knife. They said put the peanut butter on the bread. So I put the jar on the bread.
I think that's a good call out. For the sake of this example, I just want to kind of go over a couple of the object-oriented principles. One of them is encapsulation, right? So you've got everything in classes. Another one is going to be inheritance. So this grilling recipe might inherit from the recipe subclass. We might create an abstract method called cook, which I know there's lots of ways to cook these things, but maybe it gathers the tools, gathers the ingredients, goes through the instructions, and then polymorphism, right? So whether you call the grilling recipe or the baking recipe, you should receive something delicious at the other end of it. Not the perfect example. That's kind of where my head goes, and we'll talk through each one of them. For encapsulation, this is in C#. You don't need to write it down. It's out there. These are a couple of the classes, and I think you guys nailed it, right? We need ingredients. We need steps. We need to cook. And then this recipe, right? And then we've got our ingredient class and our step class. So you nailed it. Define the objects, the properties, and the actions. For abstraction, and I think, Matthew, you brought this up a couple of times. What we want to do is abstract the steps away so that we want to define the important behavior, right? Everything's going to get executed in order, but if you're grilling versus baking, you're going to have a different time, right? Baking is a science. Grilling, you can be flexible. I might like more salt than you guys. And so these are some of the methods on the abstract recipe class. The execute steps, this is private. That can't be overridden. It's just going to iterate through the list of steps and complete them. We've got gather ingredients, which is just going to gather the ingredients, print them out, and then this is a void. So, I mean, once again, this is something that just exists on the recipe that you can't engage with as another class. And then we've got this abstract method called prepare. But whenever you have an abstract method, it needs to be implemented, but it cannot have an implementation. It's very confusing, right? It's just a way of ensuring that anybody who implements the recipe base class will be forced to prepare things differently. For inheritance, in my layman's example, we're going to start the grill for a grilling recipe or start the oven for a baking recipe. And so what this is that whatever class is inheriting from recipe can implement its own definition of an abstract method. So this might be where we have those more specific, if we're sauteing something or souffleing something, we might need several different tools. Polymorphism. The idea here is that I've got a cookbook with a list of recipes. I am not going to add any recipes, any objects of type recipe into the cookbook though. So on line 4, I instantiate my cookbook. The cookbook object is an instance of a list of the recipe class. So that's just a fancy way of saying that we are putting a bunch of pages into a cookbook. A bunch of empty pages are now in a cookbook. Then I'm going to define my recipes. I've got 2 that I want to share with you today. One of them is my cookie recipe. The other is my grilled cheese recipe. One is of type baking recipe. The other one is of type grilling recipe. I'm just going to seed them both with completely real data. And then I'm going to add them to the cookbook. I think one thing that was confusing to me whenever I started learning this stuff was that I'm not putting a new recipe into my list of recipes. Does that confuse anybody else? And yeah, good. Okay, just making sure, right? Like maybe you were all super geniuses and it doesn't confuse anybody. It did confuse me whenever I went through. And that's because behind the scenes, the baking recipe is a recipe. If we take a look at the inheritance, we are inheriting all of the properties and methods of the recipe class. So these are the methods of the recipe class that we've abstracted away. These were the properties of the recipe class. And for that reason, our cookbook knows how to process each different kind of recipe. So then on line 18, we add the cookies and the grilled cheese as an array. Just a list of pages. I've written the first 2. You guys need to write the next 100 recipes. And then we're just going to iterate over each recipe in the cookbook and write a cook. So I will, let's see, we can do it right here. That's very tiny. You guys can't see that, right? This is the project. I'll make sure that everybody has a link to it right now. And we're just gonna, this is .NET, so it might differ if you're in a different class, but I'm just going to compile it and run it. And the expectation is that I would see a cookie recipe and a grilled cheese recipe. Is this too small for you guys?
No, I can see it fine.
Perfect. Very embarrassing. Okay, so I'm going to go to my cookbook, and then I'm going to run it. The expectation, cookie recipe, ancient family cookie recipe, and then grilled cheese recipe. Not so ancient, not so family. So the first one I loaded up was...
Wait, are you showing us the code itself, or are you showing us the PowerPoint right now?
I thought I was showing you guys the PowerPoint.
Okay, sorry. Just the way
I'm
that
sorry,
you're
I thought I
saying
was showing you guys the code.
No, you're showing the PowerPoint right now.
Thanks. All right, here we go.
David,
right.
I think this is the most engaged audience we've ever had.
That's so exciting. Yeah, you guys, it makes me feel good that you will actually want to see my screen rather than just get points for attending a presentation. Okay, let me clear. This is my project. We're going to program.cs. This is what you guys were just looking at. Now you see the code. Right. I use Visual Studio Code. It's a little bit annoying. Let me know if you guys are having a hard time seeing any of this stuff. I've got my cookbook application that I'm going to run. Expectation, I want to see my cookie recipe and my grilled cheese recipe. Formatting, I didn't do much for formatting because I coded this all like a Neanderthal. None of this is vibe coded. I start the oven, and then I'm gathering. So this is executing the, I guess it'd be the recipe gather ingredients method, right? Where we just iterate over each one. So we're gathering. We're going to gather 1.5 cups of flour, tablespoon of almond milk, half a cup of brown sugar, white sugar, 1 not applicable quantity of eggs, half cup of butter, and then getting started, right? They mix the dry ingredients, then we mix the wet ingredients, then we mix the dry ingredients into the wet ingredients, and then we put it in the oven for 13 minutes. Up next, we're going to start the grill. So this is, we loaded it into the cookbook, right? First the cookies, then the grilled cheese. Yeah, a not applicable quantity of eggs. I'm not very creative. I created an enum. I was hoping nobody would catch this because it's just different for different languages, but in C# an enum is just a list of properties. You can't change these without recompiling. And so it's like the value of this is 1 or 0. Okay, so yeah, Na equals 0, teaspoon equals 1, tablespoon equals 2, cup equals 3. It's really, if you're interested in more complex concepts with enums, check them out with flags. It does some binary addition, so you're like super cool. Talk to me about it anytime. I won't bore you with it right now. Right, so we put the cookies and the grilled cheese in the recipe book, and then we iterate over each one and we cook them. So that's the demo. It's not super exhaustive, but you have access, if you would like, to add your own recipes. If you want to pull down the recipe list, add them to the seed factory. All right, so now I switched back to my presentation. And so I think I need to reshare my screen. Otherwise, you will see nothing. All right. All right, so what about AI? I've talked to you guys a lot about object-oriented programming at this point. What about AI? Undoubtedly, AI is going to be a part of our jobs. Right now, I think it is not just really exciting autocomplete. I think that's where it was maybe in November. But things have changed, and now large language models are really good at predicting not just the next, not just the end of a method, right? But they can predict entire code bases. And it costs a lot of tokens to do, and I think that eventually things will even out. But right now, AI looks like it will be a big part of all of our jobs. And so if you're applying for forward deployed engineer positions or agentic engineer positions or applied AI positions, these are some of the things that you probably care about. Large language models, like I said, it would be amazing if this became AGI, but it's really just predicting the next word in a sentence. And we're giving it so much power and CPU that it can predict a lot more words. MCP, this might be one that you've heard tossed around. Model Context Protocol. This is just giving your Claude or Codex or whatever coding CLI tool. If you guys aren't playing with coding CLIs, it's just you're putting ChatGPT into your Bash shell, right? Like if you're used to creating a new project like .NET New, now you would just type Claude or Codex, and then you'd have Codex go create a project for you. So it's not earth-shattering. It's not the most futuristic thing in the world. It's not a great experience for a lot of people, but MCP is the protocol for how your Claude or Codex terminal can talk to tools like GitHub or GitLab or Atlassian or Azure. So a lot of times what people are doing now is a practice called spec-driven development. That's where you start off by asking questions, the innately human part. Instead of asking ChatGPT to one-shot a HubSpot clone and don't make any mistakes, you start by documenting what the HubSpot clone is going to do, right? And you do that one feature at a time. You practice the functional decomposition that you're so good at, Matt. You take it apart and you write a spec for each functional piece. And that's called spec-driven development. And then you ask AI to go implement the spec. That's a thing that I would do for a junior engineer now. Like that's not much has honestly changed. We're just saying maybe a computer can do it. And then there's another step even further called engineering harness, right? Where people are building suites of object-oriented markdown files that are collections of agents, sub-agents, skills, and tools. And this idea of an engineering harness is designed to prevent your coding agent from making mistakes. It works for some projects, but I will tell you, a couple of months ago, Anthropic came out with a big peer-reviewed or a big article saying that they deployed hundreds of AI agents to create a C compiler. And buried in their white paper about this experience, they say that the C compiler could no longer be built on top of without breaking something, right? So that's the risk, is that even as good as AI is, it's going to write a lot of code it doesn't need to, and it's not actually going to understand how you maintain software long term. And so, I mean, in your career, in your day-to-day, you will undoubtedly interface with these concepts. I don't want you to be intimidated by them, because they allow us to do more human things. One of the big human things that I'm working on now is asking if we should build everything that we're building. If it takes 5 minutes to build something, do we actually need it? So I hope that's a question that you guys take with you into your careers, is to challenge assumptions. And so in conclusion, learning OOP and AI gives you leverage. I fundamentally believe that. You learn how to prompt, learn how to program. Don't skip either one. It's much easier to learn how to prompt than just to learn how to program. So that's why I think that it is important to learn programming. So your product manager does not want to debug a Kubernetes cluster at 3 a.m. It's not a thing. And so keep learning. I'm going to send you guys 3 links that I take a look at pretty often. Richardson's API maturity model. It's very exciting. This is the visualization you've got on there. Design patterns reference PDF. Probably one of my favorite PDFs on the internet. And then GitHub's spec-driven dev kits. This is an MCP. If you're using Claude, you can pull it in, and it will make it better for you to write specs. And then a couple of upcoming events that I'm involved in. There's a hackathon May 7th. It's a nonprofit one, so if you want to come out and support it, or just be involved in the community, I will say being involved in communities is the most impactful thing you can do for your career, for your self-esteem. Like, you're going to spend 40 hours of every single week in this career. Making it part of your life that you're proud of and you're excited about is really important, because it's super hard to just stare at a screen and not solve problems all the time. I also want to say that I go to Block Hard Wednesdays at Cinderblock. This is a co-working space. A lot of co-working spaces, a lot of startups are going to be the ones that are hiring junior developers. I think that there is never in the entire history of development been a better time to be entering this field than now. Because there is something new every single day. And if you learn that new stuff, you have a competitive advantage over people like myself. I have 2 kids. I can't learn that much stuff. I have very little time to do things outside of work. If you are trying to enter the field and you have time to learn more and do more, you're going to be an amazing addition to any other team. And then Cincy Deliver, I don't know if anybody's going to be there, but you can volunteer for it. If you've got transportation to get up there, you can volunteer. I'm sure they need somebody to open doors, hand out bags, stuff like that. And that'll cover the cost of your tickets. And it will help you to meet people who are hiring and help you to learn skills that you can take back to your teams. I think that's it. Yeah, I don't have anything else. All right. Any questions?
No, not really.
All right.
Lauren, do you have a question? I thought I saw a hand. Okay.
Cool. Thank you guys so much for the opportunity to speak. I wish you the most luck in the universe.
Yeah, thanks so much for being here tonight with us, David. We do have a couple more scheduled for upcoming weeks, so we don't have a speaker this upcoming Monday, but May 11th, we're having a panel of former students who've gone on to get jobs in tech recently, so they can talk about their experiences. And on May 18th, Eileen from the training team, and then Danny Morton, who was on the training team, but now is a project manager on my team. They are putting together a data storytelling event, which should be really great. But thanks so much, everybody, for being here. Have a great rest of your night.
Okay, thank you. Have a good one.
Thank you.
Thank you. Thank you.